Hello, welcome back to 14 Minesweeper variants. Today, we're going to be tackling what I think might be the hardest variant in the game. Well, hardest of the 14 main variants. There are some pretty tough contenders as well, such as these two, and possibly one of these four. Maybe I think Z is pretty weird. So is I actually. But of the main 14, the hardest has to be A, which is area. So how area works is that instead of telling you how many mines are around the clue, it tells you the sum of the areas of mine regions around it. So we're going to take a deeper look into this variant in particular, and we're going to see how bad or how good it gets. So for example, this 6 sees an area of 4, an area of 1, and an area of 1, making it a 6 because 4 plus 1 plus 1 is 6. And the same goes here, this sees a 3 here, a 2 here, and a 1 here, so that is a 6. So let's take a look at some 5x5 so that we know, solve this puzzle before, so that we know, what, like how this variant actually works before we move on to larger sizes. And really, my larger sizes, I mean 6x6, I haven't really unlocked any other size yet. Alright, yeah, I've been dreading this variant, but I've been dreading a lot of other variants as well, so it's alright. The pretty tough ones beside A, I think B and F are also pretty weird. E might be weird sometimes, but E is doable. So is T. T it does give you some problems, but it's not too bad. Yeah, so in general it's just F, B, and A which are like the really hard ones. S might be some... S might give you some problem, but not really. Okay. Sorry. Alright, let's do this. We can definitely use a 0 first, because 0 means that it must touch 0 mines. So by cording, we can then prove that the 4 mines around it are all just non-mines. 4 cells around it, sorry. Alright, 2 here, we can make another deduction. This must always be a mine, because even if it saw a mine here, it must see another mine somewhere. So this is always a mine, but we don't know how far it goes. The 8 here is interesting. I think we might need to use mine count really, because yes we do, because this 8 can never share anything with this 2, right? And the reason why is because this area of 2 can never reach the 8 clue. And the 8 clue, yeah, and therefore, wherever this region is always going to be separated from the 8. Now how does that help us? It therefore implies that the 8 must see 8 mines in around it. There's 2 mines over here, and that makes all 10 mines around it. Which means that you have 2 mines touching this cell, and 8 mines touching this cell. What that therefore means is that every other number you get must be either part of the 2 or the 8. And how does that help us? Well, this mine over here... No, that could be a mine. Yeah, no. But, But at least we know that, like, I guess. 3 implies that, because this 3 must touch the 8 somehow, whatever region it comes out, the 8 must see another 5, I think. This 3 already sees 1. So either it sees 2 more that touch the 8, or it sees 1 more that touches the 8. And in either case, this can't be empty, because how would another mine here touch the 8 and still keep 3 mines? I don't think that's possible. So this is always a mine. And because this has an area of, I don't know, at most a 2, this 3 touches the 8. The 8 must see another 3 more to make a total of 8. Okay. Yeah, okay, well now then we can say that this 3 cannot have a third mine here, because we already know that all mines either touch the 8 and the 2, and a third mine over here would not be touching the 8 or the 2 at all. So that would fail, and therefore this can't be a mine. Alright. So that therefore means that either this is the area of 2 or this is the area of 2. Either one. Either way, they will exit out this way and touch this cell, which must then not be able to see any other cell. So this can't be a mine. Also implies this isn't a mine, right? And the reason why is because if it was, then we already know that every mine must either be touching the 2 or the 8. This mine therefore has to extend out to touch the 2, but in that case would make an area of 3 which fails. So that works. This one? No, this one could reach the 8 here. That's fine. And so could like most of these cells actually, up here. However, However, what I just said is that there's the 3 here that touches the 8, something here that touches the 8, right? It then requires what? Another 3 more? So what does that say about the 8? The 8 must touch 3 different groups, I think. A 3 here, up to 2 here, and then another 3 here at least. So it must touch 3 groups, and what that means is that if it must touch 3 groups, then these are all just mines. And because the groups are separate, they can't merge, so that's not a mine. Therefore, this 2 must be seeing that, this must be empty. 5 here, well 5 here and the 3 here very coincidentally sum to 8. I'm not sure if I can prove that. Well, yes, I can prove that 5 sees whatever's in here. Right? And if 5 were to see any more, which it could, but this doesn't work. Because if this were to happen, the 8 then, you know, doesn't touch this and therefore that doesn't work. I guess this can't be a non-mine, because if it was a non-mine, then this 5, again, this can't be a mine for the same reason that it has to touch the 8. The 5 is now failing because it can't reach an area of 5, it can only reach 4. So I think that means this is always a mine. Also, the 5 must see an area of 4 here. Right? Because it can't see... I mean, it only sees 1 here. So it must see an area of 4 extra. That area of 4 cannot touch the 3. So what that means is that your area of 4 must be everything else. This must not touch the 3. And therefore this is a mine, which solves the puzzle. Yeah. There you go. Alright, I stumbled through that. Hopefully I didn't, you know... Hopefully I made it decently understandable. But if not, that's okay. Alright, let's try another one, see if we can do anything else. Zeros are easy to work with. 1s and 2s I think are fine. But I know that the 2 must see a mine here. And the reason is, even if it did see a mine here, this can only have an area of 1. So it must see something else. Right. Sorry, this one either sees a mine up here or mine here. Either way, this will always not be able to be a mine, otherwise it would extend the area to 2. Well, and because of one of these being a 1, this one can't see anything else. 7, wow. Okay, my guess is that the 2 must see... I'm guessing that the 2 and the 7 add up to 9 out of the 10 mines we need. I know that because they can't match mines together, basically. Neither can this one, but this one can share a mine with 2, which, you know, prevents that from being extra mines that don't touch the 7. So that's my guess. The 2 and 7 make up 9 of the 10 mines we need. That implies 1 extra mine, but I'm not entirely sure how. Also, my guess is that a 7 sees a 1 somewhere, followed by touching the 6 here. Like, you know, whatever this is. I'm not entirely sure either. Could be different. Although I'm not entirely sure how it will be different. The 7, could the 7 see a 2 plus a 5, and the 6 sees 1 plus 5? If the 6 were to see 2 different areas, then one of them is guaranteed not to touch a 7, because there's already a solid barrier between them. So that means, yeah, and because there are 2 different areas by definition, if they were to touch the 7, I think they would have to stick together. But either way, if there were 2 separate regions, then one of them is not going to touch 7 or 2, and that one is going to have to be the last mine out of the 10. So, I mean, 7 can really only touch this area. Huh, and that's interesting, because isn't this area just an area of 7? That's just an area of 7s. The 7 has to touch all of it, which now fails. It fails the 6, it fails the 1, it fails a lot of things. So that doesn't work. In fact, this being empty at all just fails. This has to be a mine. And I wonder if I can... No, I can't. I can't use a 7 to accord that, because that requires the 6 and the 1 here to, you know, make that deduction. So I guess not. This 6 now must see a pure 6 then. Because wherever you have your mine to extend outwards, another mine elsewhere, you can't form 2 different regions. So this is just part of an area of 6. So can I just write a 6 down here to prove that? Sure. When there's an area of 6, the 1 can't touch it, so At very best, you have something like this. But the 7 must touch another region of 1 as well, because it touches the 6 plus a 1, right? So I'm believing this 6 has to extend out somehow. There's one mine here, and I guess it has to extend out this way. The 7 has to see one more. At the very least, the least amount of space it could take was here. Ah, but then these could all be mines, and I think that works out for the 6 without having to expand. So I guess expanding is not necessary then. Okay. What if the area of 1 was here? We know clearly the area of 1 can't be there because then it would, you know, join that to form an area of 2. If the area of 1 was here, it touches the 6 and cannot extend this way. Yeah, the 6 would clearly have to extend out this way. But how do we know how? Not sure. Well, what about this mine? Doesn't this mine prevent an area of 1? This would touch to form an area of 2, this would touch to form an area of 2, this would touch to form an area of 2. Yeah, there is no way, if this was a mine, for this 7 to have an extra area of 1. So this can't be a mine. Huh, alright. And now this 7... Okay, well this 7 clearly because of this has to extend outwards. But this 7 also is an area of 1, doesn't it? And that area of 1 has to be here because this is not an area of 1. Yeah. Okay. So let's get rid of that extension. We don't know about that. This has to happen because of this 1. That's empty. That's empty. This 2 sees 2, so that's empty. This 1 can't have a mine here because we already see an area of 2. So that happens. And I guess these are all just mine. And I was in fact right. There was exactly one mine here that doesn't touch the 207. Alright, so there you go. That's area. It's only just a land of scuff deductions. It's just, you know, what you think has to make sense. Because sometimes the numbers do give you outlandish, some outlandish possibilities, even though some of them might be possible. Okay. Yeah, like for example, this one, 7 and 6, really? Really? I was able to deduce this, but I don't remember how. My guess was that this is just wrong, but I don't know why. If this was a mine, I guess this 7 does need... Oh, this 7 does need an area of 1 extra from the 6, right? If it were just to form an area of 7, it would just touch this 6 immediately. Right? Yeah, because empty here and empty here to not touch the 6 would fail the 7 immediately. So if this would happen, you have to touch an area of 6. But if it were to touch an area of 6, it must have separately an area of 1 and 6. That is possible though. But does that break? There's an area of 5 here. Ah, but the area of 5 for this 6 has to go out this way. And now how does this 7 get this extra area of 2 after touching this area of 5? It can't. So that fails, but I'm not sure if that's exactly how I cut it. So there you go. Now this 7 and this 7 touch an area of 1, so they must touch an area of 6 more. This 7 needs another area of 1 then. Right? In fact, this has to be a mine. If this was empty, then this would just be an area of 7 which breaks. So I guess this has to be a mine. That's beside the point though. This can't be an area of 7, because if it were, then this 7 would just be an 8. So this must be extra, which means that's a mine, and that fulfills this one. 0 is trivial. 5 has to go out, which will extend. So this is an area of 5. Cool. Well, this is an area of 6, we know that. Because the 7 here only sees 1. So this must be an area of 6. This must be an area of 5. And I guess those subscripts that I'm putting here help us, because we know that has to expand. Now this 5 is an area of 5, but cannot wrap around here because it would then see more than 5. So this can't be a mine, which means this must now go out and out. And this 6 already sees 6, so it can't see anything else. This is an area of 6, which will touch this 6, but cannot go as far as this because that would form an area larger than 6. So this can't be a mine. That's empty. Now these are both mines to form your final area of 6. This 6 sees that area of 6, so this is empty. This 7 is an extra area of 1, so that's a mine, which means those are empty. 5 must now go here and there. This 6 needs to see more than 1, so that's a mine, which means that's your puzzle. Alright, this was somewhat okay to work with. Yeah, this wasn't that bad. Alright. Just have to think about it. The start is always the hardest part. Oh well. Sorry. Alright, next up. 1 and 2. Well, the 2 must see 1 more than 1. So because this thing can only have error 1, this must see extra, which gives you that. 4 and 5. Well, there's 1 here, so this 1 will see that, so that's empty. No idea what happens next. The 5 and the 4 probably do something though. This 5, for example, must see more than whatever this cell has, because this cell only has a maximum value of 4. So it must see that. This 4, well, I guess what's interesting about it is that could this 4 be a separate 2 areas? I think the answer is no. Because if it were a separate 2 areas, then you know, how would this work? This 1 implies that this is a 3, but in doing so would force this 5 to only be a 3, which fails. So it doesn't work. This must be a singular region of 4. And that singular region of 4 could happen in a few ways. It could have an area of 4 like this, which prevents from touching the 5, or it could touch the 5 like this. And in both cases, do actually force these 3 to be mines, I think? No. Oh, right, because that could happen. Well, yeah, I guess so. But we do know at least that this has to happen. This 5 I don't think can actually go down this way now, because if it did, then, you know, how would this 4 get an area of 4? It can't, because either mine here would bring it to an area of 5, so that can't happen. Sorry, I have a runny nose. I have a cold. Anyway, so okay. So sorry. This 5 means that this area and this area sum to 5, don't they? And so this area itself can't be its own 5. This 5 has to extend, so that's a mine. I don't think this 5 can have a mine here now, because that will either force this to be an area of 3, which is wrong, or it will force this to grow out to this, but that's also wrong. So this can't be a mine. This has to be an area of 1 as well, because we now know this is an area of 4. And this 4 must see 3 more. This 5 must see 4 more. Which again feels very similar to whatever this is. This 4-5 and this 4-5, they're just rotated versions of each other. Anyway. Well, I think this has to be a mine. Because if it wasn't, this 7 just sees an area of 7. This 4 and this 5 then feels really suspicious, right? Because this 4 and 5 clearly cannot connect to the 7. Even if they were to share 4 cells with each other, the 7 here, plus the 4 here, plus the 1 here, gives you a total of 12 mines at least, which definitely doesn't work because there are only 9 mines left. So the 7 can't have its own 7, it has to share, right? Which then means therefore it has to share, and by that, has to have a mine there. Of course, by sharing, it means it has to have my mine here. And this is an area of 3, which does work if it touches the 4, to give you an area of 4. I'm not sure if it has to or not. Does it have to? Well, we can try. If it were to have its own area of 3, plus this area of 3, the 5 could see that area of 3 the 4 has, and must see 1 more as a result. This 1 must see 1 more. And this doesn't work because coincidentally this actually gives you an area of 8, which is just barely not enough. We don't have enough mines for 8. So I guess this means that this area of 3 must extend to the 4. No? Oh, because this area of 3 already has 1 mine. So in fact it is barely possible. I just miscounted. I counted the mine that was on the board as one we didn't have yet. Okay, my bad. So what did we do? We did this, we did this, we did this. We did this, and therefore this. Then we did that. And we know there's an area of 3 here. Okay. Now that we know that's possible, what then? Well, this doesn't work. This can't be empty. Because this 5 will now have to see an area of 4 here. But then brings the 4, which now sees an area of 5. So, no. This can't be a non-mine. This has to be a mine. And now this can't be a mine, because if it were, then the 1 here would just break. Because you see 2 mines. So you have this. Now this 4 must see an area of 4, so that's a mine. And this is an area of 4, which we know works with the 5. We also know it can't extend out this way, because then this 4 would see 5 mines total. 7. I'm pretty sure they share. They clearly share, yes. And because it's an area of 4, I'm pretty sure they share 3s. If they don't share 3s, what happens? Well, firstly, this 4 must see something, so that's a mine, definitely. Yeah, and now this 7 only sees an area of 4 here, so it must see more, which means that's always a mine. And that area of 3 is now complete. This area of 4 must extend outwards. And with 0 mines remaining, those are 2 mines. Sweet. Okay, not that tough. I'll just keep going. Wow, that's minimal. This 3 must go out this way. This is an area of 3, which can't touch the 2 therefore. Must go out. Well, it either goes here or there, and either way cannot reach here. So if this were a mine, it will always hit an area of 4. So that's empty. In fact, if I did this, does that... Oh, it does. Wow. Okay, well, we also know that wherever the mine is here, we're given this an area of 3, so it can't see any further. These are empty. That's a mine, which is its own thing. This 2 sees one of these being mines, and therefore this has to be empty. One of these is 1, so this 2 must see 1 more. Okay, the 5 might be useful now. The 5, even if this were a mine, we'll have to see 3 more, so this is a mine. And in fact, if the 5 sees 3 more, this can't be empty. Because this 3, yes, this 3 now must extend out. This is an area of 3. That gives us the benefit of making this empty and this a mine firstly. But also, the 5 sees only 3 here and 1 here, so it must see 1 more. The 5 sees 3 here and 2 here, so it can't see any more. This 4 must extend. The 6... Well, this is empty. This is just an area of 6 which fails. So this is a mine. This must have an area of 3 now. So this 6 seeing an area of 3 must see another area of 3. So there you go. 3 here is complete. 2 here can be completed. 5 must see another 3, so there you go. Alright, that wasn't too bad. This is actually, I think, one of the easier A puzzles that we've had. Alright. Let's keep going. I want to work on the smaller numbers today. Okay, this one is obvious, this one is trivial, this one is also trivial actually. This 3 is less so trivial. 4 must extend out, this is an area of 4. This is an area of 1, so this 6 must be an area of 5 more. And that area of 5 can't reach out this way, so this can't be a mine. Now this 4, I mean this 4 can go all the way in. This 5, I don't know how far this 5, this 5 has to go up here though, at the very least. And because this 5 now can't all go all the way here, this can't be a mine. 0 helps us. 5 here, I mean 5 here could see this 5, although it doesn't have to. Well, this 4 has a touch. This 4 can't touch the 5. So at the very most it goes up here, meaning it has to go down here at least 2 mines. Okay. I'm not entirely sure what we can do next. We have 8 mines left. Does that work? I think the answer is no. This 5 has to touch this mine area. Can I prove that? This 1 sees 1. This 3 will see 3. And this 5, well, if it didn't touch this, we have to see an extra 5. That doesn't work because this 3 can't touch this area of 5. It has to make its own area of 3. This 5 will have to make its own area of 5 by our hypothesis. This 5 has 3 more to go, and that very clearly adds up to more than 8. So no, this 5 has to touch this area here. And by that logic, I'm pretty sure must have a mine on its left. Yes, okay. And also has to connect to this, so this is a mine. Now this can't be a mine because if it were, then it definitely can't do this. So, okay, 3 now can't touch the 5. Must have its own area of 3, which actually coincidentally finishes that. 5 here probably touches this area of 5. Yeah, there's no other way for it to be doing that. You know. So there you go. Alright, cool. Alright, let's keep going. Alright, 6 is doable. That's a mine. This is an area of 6, which clearly this 4 can't touch. This area of 6 touches this 6, but can't go all the way here because it would then touch the 4, which it can't. This is an area of 4, which this would complete, so that's not a mine. This 6, well, I don't know what this 6 is. This is just an area of 6. This 7 has, I think this 7 has to see the 6 and more. If this is empty, yeah, then this doesn't work, so this has to be a mine, which connects to this 6. So this also has an area of 6, meaning this 7 must see one more. Now obviously it could do it in a few ways. It could do this, the 6 goes out here, or it could do this, and then there's a 6 contained inside. Both of them work. But in both cases, these are both mines. This is another area of 6, which means this 6 can't see anything here. And you either have this must be empty, that's a mine. Oh, so these are both mines then. We just don't know which is there. So this is also empty, I think. Yes. And now we know that this can't go out here because that would fill this area of 4. So there you go. 7 is not complete, so that's empty. This now must be a mine, which is an area of 3. This area of 4 sees a 4, but this 4 can't go all the way up here because of the 3 there. So this can't be a mine. This has to escape out. And now this is a mine, so this can't go all the way up here, so this can't be a mine. There's 3 mines remaining. 1 will belong to this area of 3, and 2 will belong to this area of 4. So that means this is always a mine. Whoa, that was a lot of lag. And this area of 4 can't reach here or there. Alright, so that's your puzzle. Cool. Alright, A6 by 6 is warming up to me. I'm sure the 7 by 7s, but an 8 by 8s are going to be way, way worse. But very theoretically speaking, I'm pretty sure you could have a what? You could have a puzzle with the number 14 in it in this clue. Technically speaking, I think. This 4 must see one more. This 4 sees an area of 4. This 7 must see 3 more. Not really sure how this will work. I think if these were split up, I think that fails. This is a mine. Yeah. And this 3 always sees an area of 3. There's an area of 3. There's 4 over here. That makes out your 7. This area of 3 must touch this, so can't go here. But this area of 4 can in fact go there. This area of 4 can't touch the area of 3 though. And this area of 3 would have to touch this area of 4, right? Yeah, because if it didn't, again, can't touch the area of 4. So at best, would fail the 3. So this is a mine. This is empty. This would be an area of 1, which means that's not a mine. This is an area of 3, which very likely touches this area. Can I prove that it doesn't? Yes, because if it didn't touch it, if this 3 doesn't touch that, then this must be empty. This 3 can only be completed like so. And how would you make this an area of 3? Going up would fail. So this area of 3 has to touch this area of 4, which now means that this must be empty. This must be a mine, which gives you an area of 3. This area of 3 is complete, so this must go up, which means this. Which means this. This 3 must touch 4, so that's a mine. This is your area of 4 going here. This 6 must see an area of 3 more. Which I think by mine count will help, right? Sorry, I'm just having a very hard time drawing this 3 here. Yeah, so there's 2 mines connected to this 3. There's 1 mine connected to this 4. That will give you all 3 mines remaining. Those areas can never touch this cell. or this cell. Now this 7 must actually touch both, right? And how would you do that? Without the 3 and the 4 touching each other, the only way is like this. Cool. Okay. Okay, A6 by 6 is not too bad. In fact, it's so not bad, I feel like I should end the video right here. Although, I think I'll just go for more. Alright. See if I can finish all 10 by today. Huh. We're seeing a lot of 6s and 7s. I'm pretty interested to see why. Okay. I think this is one of the interesting cases where 6 in fact can be equal to 1 plus 5. Then this 7 can see another 2 more. Or it could just be an area of 6. I mean, okay, we don't know, but this is definitely not a mine. This isn't a mine. This is very similar to a puzzle that we've done before. It's just 90 degree, 108, no. Flipped horizontally. No, flipped vertically, sorry. This side is flipped vertically. But this is an area of 3. How does that help? How does that hinder things? This 6. Well, this 6 could still be a 1 by 5. 1 plus 5, sorry. If it were an area of 6, how would that work? If it were a pure area of 6, this is always empty. And I would say is if this were a mine, this is an area of 3, wherever the 6 extends, we'll only be able to see areas of 3, which means that it can't see an area of 6. So now this is a mine with an area of 3. This 6... should it see this area of 3? If it does see this area of 3, we need to see an area of 3 here, which definitely breaks this 6. Alright, so can't go up here. This 6 must therefore see an area of 6, which means this is always a mine which must expand. This is at least a 6, but could be a 5. I'm not sure if I should write it out like this because it just is plain ugly. This 7 though must see at least 1 more, so this has to be a mine at the very least. Giving you this. This 5 means it's an area of 2. Aha! So now we know this is an area of 5. That's a mine that's not. This 3 is complete, this must go out, which gives you an area of 5. Which gives you an extension for area of 5. 7 must see something that's area of 5 more, but if it were to see its separate area of 5, can't actually make it out without touching this. So I guess it just has to see this area of 5. Which means that this can't be a mine, this can't be a mine. 6 sees an area of 5 at least, but must see at least 1 more, so that's a mine. Must also see an area of 5, so this gives you that. 5 here means that's empty, and 2 mines remaining gives you those 2 mines. Nice. Alright. Next up. Oh gosh. What is this? Okay, well clearly this can't be empty, because this can't be an area of 7. So this has to be a mine here. This is at least a 4, right? Because this can't be anywhere more than a 3. So this has to be at least a 4. The 2 has to avoid that. It can really only do so by doing this. Ah. I guess what's interesting about this being an area of 4 is that this is 8. How does 8 work? Well, this is not a 4 then. This 8 must see a 6. Because if it were to see anything else, this has to extend out because this is at least 4. Now, this 8 can't form any new areas, and for it to be an 8 with 2 already there, it must see 6. So this 7 must see exactly 1 more. 1 means that's empty, 3 means these are both mines, so a total area of 3. This 4 must see 2 more. And those 2 more can't actually hit the 6. I'm not entirely sure how we can resolve that. You could have a mine here in this area looking like this to touch the 7. In fact, the 7, I don't know if the 7 can be an area of 7. If the 7 had a pure area of 7, that doesn't work. And the reason for that is because, this 6 needs 4 more, this 4 needs a bunch more, so how would you do all of that with only 7 mines? This 7 must clearly have 2 separate areas. And I think this one has to reach the 6. Okay, I made a mistake there. This one is just a 1 then. Unless this is wrong. No, this 7 has to see 5 more. Yeah, so every mine has to either touch the 7. Wait, what? No. This 7 has 5 more, but this 7 could reach here, which takes up some mines here. So this doesn't necessarily have to have all 5 mines touch this. In fact, this 4 must have 2 more coming out of it, and those 2 more cannot be attached to the 7, otherwise the 4 would just break. So those two more are going to be replaced by these two mines here. So it is in fact the truth that this has to reach here, right? Unless this... But if this was the case, how would this 4 see 2 more? It just can't. Because none of these will be mines. So no, yes, in fact this has to go all the way here, and then one of these are mines. This 7 will see 6, so this is empty. That happens. This 2 means that this has to be empty, so that's a mine. This 6 means that's empty, so these are both mines. There you go. Nice. Alright. I was starting to think that this puzzle type is a lot more logic than it is puzzle solving. Not logic, it is always logic, but this is a lot more common sense than it is puzzle solving. Yeah. Okay, 4 means that's a mine at the very least. That's a mine at the very least. 6, 4, and this is an area of 3, so that's at least a mine. I'm not entirely sure how much of it is mine though. Alright, let's think about this more logically, I guess. If this was empty, this 4 needs to see an area of 4 here, this 5 needs to see an area of 5 here. This would require 3 more here. This would require 2 more here. This requires 3 more here. And that's what? And that's a total of 8, right? 3 here, 2 here. We have 1 more mine, which could append the 6. So how that could work is that you could have this, this, and this with a mine here for the 6. Ah, and I guess the 5 could take the 4. Huh. You know what? This is valid. I found a valid solution. But we're not about valid solutions, we're about solving the puzzle. I'm just not sure if this is the only solution. Probably isn't. But at least we've proven that in some way this being a non-mine is valid. If this was a mine, it's even better, I think. Well, if this was a mine, this is an area of 4. Interestingly enough, this area of 4 doesn't allow it to touch the 6, right? Yeah, it doesn't let it touch the 6. And so this 6 has to see 6 of its own. Even if it both touch this 4. This has to see 1 more. And this actually fails. Because this must see 2 more here, 1 more here, 6 more here, that makes 9. Huh. Wait, is this also possible? No, because this 4 must then see another 1. Because this is an area of 3. So that fails. Aha. So this kinda should be a mine. Alright, gotcha. This is an area of 4. This is an area of 5. Which I think has to touch a 6, so this is a mine. Just not sure how it touches a 6, it just has to. And there's a 1 here. This 4 has to touch a 5. So I think this is also an area of 4? No. Oh, I guess the 5 could touch the 5, yeah. But my point still stands. There's an area of 4, there's an area of 5, which must touch the area of 6 in some way. This 4, well, this can't go here. 0 means those happen. Now this is 4, I don't know about this one. But now this 5 can't touch this area. So this can't be a mine. I mean, it could. It could be a mine, yes. But this 5 I think has to touch an area of 4 as well. This is an area of 4. I think this is a mine? No. Oh, because this area of 4 could touch it. Ah, so yeah, a lot of common sense, but a lot of common sense that I don't have. Okay, okay, we're gonna mark these areas again. 5, 5, 4, and then mine here, which is a 4. I think this means this is empty. How do I know? I know because this 5 sees 1 from here. It must touch a 4, right? Yes. So now this is empty. Alright, we know that now. So this now can't see that, so that's a mine. Okay, gotcha. Now this must be empty. So this 8 must now touch both areas of 4. Because this area only touches 4 once, it must touch 4 here.
That's empty, that's a mine. 3 mines remain. There's 1 here and 2 of which are spent on the 5, so there's no mines anywhere else. That is useful. And there you go. Cool, alright, this took me quite a while, but I think we finally got it. One more puzzle to go. Oh wow, small numbers this time. Okay. Let's see. Okay, that's really weird. I don't know about this too. If this would have happened, nothing happens. I mean, any mine here would just work. If this is a mine, oh yeah, okay, because one of these are mines is just empty. Alright, I forgot about that. Okay, we're getting the bigger numbers again, which is more like it. I think that this can't be a mine. If it were, or if it were, this 4 would require a mine area of 2 here at the very most. This could also be empty. But this can't be a mine, can it? If this were a mine, this can't be a mine because of this 1. This has a maximum area of 2. So this 4 must have another 2 somewhere else. And in fact, I think the only way for that to happen is this. I mean, that looks fine. Okay, I guess there's nothing wrong with that. Nothing wrong. What is going on here? Okay, I have a hint rating I can use, but I'm not sure if I want to use it. We're really close actually, so. Let's see. Oh, well, this has to be a mine, because if it wasn't, then this 4 just sees a mine area of 4. This is just a mine. If this has an area of at least 2 anyway, because this has an area of at most 2. This can't be a mine because if it was, anything here would break. That would render these both non-mines, and then you have an area of 2 here which fails. 6. Well, 6 clearly probably implies that the 4 and 2 are separate mine areas which meet up with the 6. Could also mean other things. Could also mean this and this. Well, what could this mean? If the 4 and 2 share something, they'll have to share only in the region of 1. This is a region of 3. And the 6 must somehow see 2 more. Which, how would it? There can only be 1 here. So it can't see a region of 2 here, it can't see a region of 2 here, it can't have 2 added to it. So in fact, I think this is in fact an area of 4. This can't be an area of 1. So it must be an area of 2. Which means this is empty. You have your mine here. Also, I don't know if that was necessary or not, but sure. That's empty. This 3 must see 3 somehow, but this 5 must see more than that. I think this feels very similar to the 4-5 situation when you counted. I mean, that's a mine. 7. Well, 7 sees whatever 6 sees plus more, so I think the only way that's solvable is like this. Yeah, the 5 must see 3 more, so that happens. And there's 2 mines remaining. They can't both be attached to this 3. So one of them must be unattached, which means this. Nice. There you go. Some pretty interesting logic there, but I guess that works. Well, that's area for you. Yeah, area's a little bit of a something. It's okay though. Alright. With that though, I think we'll end off here. I'll try to do more A's. Hopefully we get through it all. area, my beloved. So is balance, my beloved. G might be difficult at some point, but I didn't find it too hard. Cause I'm pretty cool with area though. Area's like this thing is fine. It's fine to me. Sorry. Yeah. Okay. But well, I'm not sure. Yeah. Anyway, enough yapping. Hope you enjoyed this video. I'll see you guys next time. Bye bye.